Alright, so I'm going to pick up right where I left off in class. This video is intended just to kind of help you get through the rest of this section and be kind of a guide to help you get your homework done tonight. So I'm on the middle of page 301 where we left off. So we had just talked about the sequence that represents the formula for interest earned, and this is compound interest, now not simple interest. And the main difference is now each year the interest that we are gaining is added towards our total, and then that new total is what we're finding the percentage of to calculate our interest for that year. Okay, so our first one that we did, problem one in class, was an arithmetic sequence. But this one now is going to be a geometric sequence, and the common difference or common ratio, which is common ratio in this case, is going to be the 5% each year. Okay, so now I'm going to go on to number 4. So number 4, 5, and 6 are talking about the formulas that we come up with now from a geometric sequence and turning it into a exponential function. Okay, so I'm going to go ahead and go to the answers here in a second, but let's look at number 4 first. It says substitute his original principle, which is P0, and the common difference or common ratio, which we know is common ratio, into the explicit formula for a sequence. So we know our explicit formula for a geometric sequence is Gn equals G1 times R to the n minus 1 power. Okay, so that's what we're going to do here is we're going to substitute it in. It's Gn equals G1 times R to the n minus 1. We're plugging in what we know. So it's Gn stays the same. P0 is our principal amount that we start with, and that's getting times our ratio, which is 1 plus R, which is our rate, and that's getting to the power of n minus 1. Okay, so then 5 says, let P of t represent the account balance after t years. Remember that time t is 1 less than the term number n. Write a formula. Okay, so same thing, except instead of n minus 1, it's just t, because this is years. So we don't have to account for the first term being the 0 year anymore, because now we're in terms of t. So t1 is year 1. Okay. Now 6 says, write the balance in Raul's compound interest account as a function of time t. Recall that the original principal was 1,000 and the rate is 5%. So we do the same thing, we just plug in our numbers. So we have 1,000 is our P0, that's like our starting point of a sequence. Our rate is 1 plus 5%, which when we turn 5% into a decimal, it's 5/100ths, and to the t power. And then we can just simplify that. We just really just add the 1 and the 5/100ths to 1 and 5/100ths to the t power. Okay? So now we have two different functions, one for compound interest and one for simple interest. All right, so now on page 302, it says determine which function family this represents. Well, we know that's exponential because the t, which is our variable, is an exponent. Okay, so it's an exponential function. 8 says use this function you wrote in question 6 to determine the account balance after 8 years, 100 years. So this is the same question as problem 1. It's the same rate, the same principal amount, but instead of being simple interest, this is compound interest. And we're going to see how much of a difference that makes. So if you recall, after 8 years, on the simple interest, if we go back a few slides here, after 8 years, it was $1,400. And if I go forward now, when we use our new formula, it's $1,477.46. Okay, so by doing compound interest instead of simple interest, we get $77.46 more in just 8 years. Okay, so we're getting a lot more money by doing compound interest because each year our principal total is growing. Okay, so we're getting 5% each year of our total instead of 5% of the principal amount that we started with. Okay, and if you remember, for number 9A to reach $1,600 was going to take us 12 years with the simple interest, but with the compound interest after we solve, it's only going to take us 10 years. So it's going to take 2 less years to get to that target of $1,600. Okay, so again, compound interest gives us a lot more money over time. All right, so that was to kind of help you get going on your homework. So at the bottom of page 302, it just reminds you of the formulas. Okay, so the simple interest formula is P0 plus P0 times R times T. Okay, the compound interest formula is P0 times, in parentheses, 1 plus R to the T power. Okay, so you can use these two formulas. This is on page 302. You can use these two formulas to help you fill in the table here on question 1. And then question 2, you're going to analyze that and kind of decide at what rate is it better to do the compound interest, okay, versus the simple interest. Okay, so your job is to think critically and think about it as if it was your money. Okay, if it was your money, which one would you invest in and why? Okay, and it might differ depending on how long you're going to keep the money into the account. Okay, so try to keep all those things in consideration when you're determining which account would be best. Okay, I hope this helps with your homework tonight. I look forward to seeing you guys in class tomorrow, and you will have pages 303 and 304 done. All right, have a great night.